All right. Okay, we'll get going then. Hello, everyone. Thanks for coming to my talk. It's kind of funny that there is this thing in the middle, so it kind of divides the room. Before I get going, I just want to tell you a little bit about what you should expect from this session. The title of the session is SLSA, SBOM, and Software Supply Chain Security. What I'm aiming to do with this is sort of like a basic introduction to what people mean when they say software supply chain security. So I'm going to be focusing quite a lot on the basic concepts and the basic frameworks that exist. I'm going to do a demo which illustrates one mechanism for protecting your software or trusting your software. But pretty much everything I'm talking about today is what I want to focus on is more the high-level idea of how these components kind of plug together to make sure you don't get bugs into your production, or you don't get security holes into your production. How you implement them is really up to you. All cloud providers today have some sort of software supply chain tool. There have been companies doing static code analysis and vulnerability scanning tools for ages, way before cloud even exists. So how you implement these concepts is really up to you. I'm not trying to influence you. I'm going to talk a little bit about what how we do it at Google Cloud. My name is Abdel. I'm based out of Stockholm. I work for Google. Been 10 years at the company. I co-host a podcast called the Kubernetes Podcast by Google. Anybody listens? One person, okay? And the rest of you? I'll give you a minute to sign up. I'm just kidding. That's my Twitter or X or whatever we call it these days. And before we talk about why people should care about software supply chain security, I'm going to tell you a couple of stories or anecdotes of why this term, software supply chain security, is becoming very important these days. This is something we haven't heard of probably before COVID, but the more and more you go to conferences, the more and more you go to, exhibitions, there are companies and providers kind of providing software around this. And the reason is because for pretty much the entire time as an industry we've been building software, we've been using some really basic concepts of getting software from where it's developed, which is typically a developer laptop, all the way to production, right? And this sounds familiar, right? Like you have your source code, you have some dependencies that you pull from the internet, and then you put your source code and your dependencies together, and you build your software. If we really want to be very realistic, that dependency block should be way bigger than your source code block because you're typically not writing all the dependencies, you're just relying on somebody else's work. Your code source is probably something around 5 to 10% of the actual software that you're writing. Then you package your application and then you run it in production. But what a lot of people actually doesn't realize is that the same exact process is followed for building dependencies, right? A lot of people building libraries, they just have some sort of CI/CD pipeline, automated CI/CD pipeline. But what they also have is they also have dependencies. So basically, all your dependencies contain other dependencies inside of them, right? And when you are doing an NPM download from the internet, you're just putting a bunch of libraries, which are composed of libraries built by people who you don't even know who they are or where these libraries are coming from. And this is all good and rainbow colors and nice, but what have happened in the last 10 years or so is that people who are really trying to hurt you, so bad actors, attackers, realize that trying to target production systems is becoming harder and harder because as an industry, we have become really good at keeping people out of our production systems. I mean, people still screw up. That's not the point here, but like we became better. We invented all sorts of technologies. We invented WAFs and firewalls and, like sessions and login and all these things that just make sure, okay, like my production system is as safe as possible. It's only accessible by some automated systems. What attackers have realized is that one other way we could try to get into your production system is go infect something that you are using, but something that you're using early in your development cycle. And that thing is typically your dependencies. So if I inject a backdoor into a dependency that you are using, and you pull that dependency from the internet, use it to build your software, well, now I have a backdoor inside your system, and then I can make that backdoor do whatever I want, right? So a couple of examples, Log4j, you are all familiar with it. SolarWinds is a company that makes monitoring software. They basically had a backdoor a crypto mining backdoor in their software that distributed to their customers. And one of their customers was the Continental Pipeline in the US, which is the company that supplies the East Coast with oil and gas, and I think only oil. And that created a massive problem. So the company, Continental Pipeline, were locked out of their systems. All their computers were locked out, and there was like a thing that says pay X number of Bitcoins to get your laptop unlocked. And it created chaos, and there was like 2 hours waiting lines because people freaked out that they're not going to be able to buy gas anymore, right? And I'm going to give you an example that happened actually not far away from here. It happened in Sweden. I live in Sweden. So you know Coupe, I guess, if you are from Denmark. Coupe is a very popular supermarket chain. Last year, they had to close all their stores, 500 plus stores, for 24 hours. Because, as any modern supermarket, Coupe has a bunch of self-checkout desks in their supermarkets, right? Like, it's where you go and you scan your own articles and stuff. And those self-checkout booths, they were managed by a third-party vendor. It's whatever the company in the middle, the IT company. And that IT company used a software called Kaseya. Kaseya is an IT management asset software, basically a glorified database with a beautiful UI that tells them where are my computers, which MAC address they have, and which store they are installed on. And so Kaseya, as any company, has developers, and their developers use dependencies from the internet. So they pull some sort of dependency which has a backdoor. They built it into their software. They distributed it to their users. One of their users is the vendor that manages cashiers on behalf of Coupe, which then distributed to Coupe, and for 2.5 months, Coupe basically had the backdoor into their self-checkout machines, and that backdoor was just leaking information to a remote server about what people are buying. So it was telling, there was somebody that showed up and bought 1 pint of ice cream and diapers and stuff like that. Luckily, there was no credit card information leaked, because in Sweden, the stores cannot actually store credit card information. They have to be processed by the terminal machine, and it's directly with the bank. But the point I'm trying to make here, the illustration I'm trying to make, is if I am really trying to hurt a specific company or a group of companies, instead of spending money and time trying to attack in the production system, which they probably have becoming very good at protecting, I can just go and look what popular libraries people are using and try somehow to put a vulnerability in one of them. Vulnerabilities, by the way, does not necessarily have to always be put in libraries by bad actors. They could be just bad developers, right? People don't know what they're doing, and they just build stuff that doesn't work, right? I will give you another example. I think that happened a long time ago, and I think a lot of people have probably forgot about it. If you have a MacBook, you're using Homebrew, right? The software to deploy stuff on your MacBook. There was a security researcher from Australia like 10 years ago that started contributing to Homebrew. Homebrew is open source, right? It's on Git. And they started contributing to Homebrew, and they reached a certain number of contribution where the Homebrew community, they were like, oh, this is a nice person. So we're just going to give them commit code to Git, right? So they made them a committer. And the point that the researcher was trying to prove here is, well, now I am a committer, which means I can potentially just commit code, merge it, because probably the main branch of that Homebrew did not have main branch protection, did not require a pull request with a reviewer. Then I can just commit code, and no one will see what I'm committing, right? And so the point of this example I'm giving is you could potentially be dealing with people that look on the surface that like they are like legitimate actors, but once they have access to your backyard, they turn into illegitimate actors, right? So these are all examples to basically say your CI/CD pipeline is probably full of holes, right? And those holes can be exploited in so many different ways. You could start by injecting bad code, internal malicious actors, people who work for you, but they are there to hurt you. And unfortunately, in our industry, internal malicious actors is not something a lot of people talk about a lot, I guess because we're ashamed of the fact that we hired somebody without probably doing, by we, I don't mean us, Google, but generally speaking as an industry, we're probably ashamed of hiring somebody without doing proper background check. And then when we realized that they were bad actors, we just fired them and never report this publicly. So we don't really have kind of public information about how often this happens. I have to bet it does happen. It's a non-zero probability it happens. Somebody could compromise your source control, right? Happened before. Somebody could compromise your build system. My favorite example is there is a managed SaaS product called CircleCI. I don't know how many people know CircleCI, like one person in the back, 2 people, 3 people. You were impacted by the AWS keys leak from last year? No? Okay, good. So last year, CircleCI leaked some of their and their customers' AWS keys to the internet. Again, this is not to say AWS is bad or Google is bad or whatever. It's just like people are people and people make mistakes, right? I think what was really frightening with that specific example is that they did not only leak their customers' keys, they leaked their own keys. So they leaked keys that they are using to run their own build system on top of cloud provider, which means that whoever got access to those AWS keys could potentially have access to the entire build system of CircleCI. Again, not to point fingers at particular CircleCI, but my favorite word to use is shit happens, right? Like stuff like this can happen to anyone. You could have a compromised package. One very common thing that happens is you build a software based on libraries that you scan and they look legit, but they just have some sort of built-in loop that once they are running and they can talk to the internet, they will curl download a bash file and run it locally. Like about, I think, 50% of all container escape attacks happens this way, which is essentially you are building a container using a library, but that library, once it's running, it will download something from the internet to try to execute container escape attack or flood memory with some random stuff or something like that. So this is basically what we mean when we say software supply chain security. Software supply chain is the process by which we get software from where it's developed, typically a developer laptop, a computer, all the way to production. And the term security means basically how can we secure this entire process end-to-end, right? And so this kind of triggered a bunch of efforts in our industry. These efforts are all happening in like a distributed way, and everybody's trying to solve the problem their own way. I think the most common two efforts are what we call shift lefts. So shift left in security was copy-pasted from DevOps, because like the whole point of the DevOps movement is this shift left, which is how can we make developers responsible for production, right? And in security, it basically means how can we make developers aware of what they are doing. Also, how can we trust that the software coming from our developers are actually coming from our developers and not from a malicious actor. So in the shift left movement, there is also this concept of establishing trust, which I'm going to show an example of how establishing trust across your software supply chain can be done. And then the other thing is zero trust. Again, zero trust in security have been used in various ways. In particularly cloud environments, when we say, well, cloud, microservices, distributed environments, whatever, when we say zero trust, it specifically means the traditional way of building a microservice system is that you have a front end that receives requests, authenticates users, does all the fancy schmancy, like, is this a good request, yes or no? But then once that request is sent down to the microservices, usually there is no authentication because you just trust that the front end knows what they are doing. In a zero trust environment, usually you would send the token of that user, or you would exchange the token of the user for an internal token and send that token down across the microservices, and then have each microservice verify the token of both the user, and then ideally, if you are really paranoid about security, verify the identity of the service calling, right? And here, there is various ways you can implement this. The easiest or the most common one, I mean, I don't know if it's the common one, but there is a tool in the open source space called Spire, which uses a protocol called SPIFFE, which uses basically tokens, IJOT tokens, to do microservice-to-microservice authentication, right? So these are the kind of two big culture changes, if you want. Realistically speaking, an effort started a few years back called SigStore. So SigStore is an open source project that has contribution from multiple companies. And the SigStore project is all about establishing trust through sign-in and verification and monitoring what people are doing. They have a bunch of tools, open source tools, obviously. So yeah, SigStore is under the control or under the leadership of something called the OpenSSF, which is the Open Software Security Foundation. So that's a foundation under the Linux Foundation. It's a sister organization to the Linux Foundation. without going too much into details, and then it has collaboration from a bunch of companies. And basically, what all these companies are doing, they're just contributing their own ways of implementing software supply chain and trying to make it public so other people can use it. And so they have a bunch of components. Some of them are tools like Cosine, which I'm going to show you today. It's basically for signing and verifying container images. They also have a certificate authority. They have something called a transparency log. It's Recore, it's called. Essentially, what Recore is, it's a searchable ledger that you can use to search for a library, and then you will find, if that library have been signed by the tools from SigStore, then there will be an entry in that ledger that says, this library have been signed by this user, and this is the identity of the user that have signed it, etc., etc. Another effort or another thing that SigStore have done is that they came up with this thing called SLSA. So it's written SLSA, but it's read SLSA, which stands for security levels of software artifacts. What it is, essentially, it's a framework, it's a set of practices that, or a set of requirements, rather, that if your build system, if your supply chain system meets those requirements, then it is compliant with one of the 4 levels. And I'm going to show you a little bit the details. I don't want to bore you too much with the details, but this is how it looks like. Essentially, you see on the left side, there are a bunch of requirements for source management, for how the build happens. Provenance in SLSA world essentially means like tagging the artifact with the origin. So essentially adding metadata to the artifact that says who built this artifact, where it came from, which GitHub repository the source code is stored on, etc., etc. And then on the columns, you have SLSA level 1, SLSA level 2, 3, and 4. And my favorite example is level 3. I think, in my opinion, so by the way, SLSA, the framework, got a very big update recently. They came up with something called SLSA version 1.0, which only focuses on the build part. It doesn't focus on the source control part. But a combination of the old version of SLSA and the new version of SLSA, I think a very good target that people should aim for if they care about these things is SLSA level 3. So in SLSA level 3 world, basically what it says is, well, you have to have some sort of source control, right? So Git, right? Which everybody have. You have to have a verified history. So you have to have commit logs, and you store these commit logs for at least 18 months. You have to have, you don't need 2-person reviews. 2-person reviews is only required for SLSA level 4. I would argue it's probably required for everyone, but that's whatever. Your build system is scripted. Your build system runs inside ephemeral environments. Ephemeral environments means that 2 builds are not running into the same worker node, and that the worker actually is recycled after each build. That's to avoid things like caching and problems. Your build system is isolated, ideally. Isolated means if you are... How many people here use Argo CD in their day-to-day work? 1, 2, 3 people. OK, so your build system is not really isolated if you're using Argo CD. Just an example, because Argo CD runs on top of Kubernetes. It uses pods to run the build. But on Kubernetes, pods are not isolated from each other if they run on the same node. So just an example of what is not isolated. So isolated ideally means that you run in some sort of like enclave environment or maybe a dedicated virtual machine or something like that, etc., etc. So I'll share the slides later, and if you are bored on the weekend, you can probably read them. But this is what software supply chain security according to SigStore means. So when SigStore says we want people to be able to implement our framework around SigStore security, this is what they mean. What they mean essentially is I am a developer, I'm writing code, I have to publish something, a binary, an artifact, a library, whatever. Well, before I publish said artifact, I have to sign it with a certificate that proves it's coming from me, right? Where do you get the certificate from is really up to you. You could use their own certificate authority. So SigStore have a publicly available certificate authority that anybody can use. Or you can just create your own certificates. Or you can use HSM, a hardware security module, to create the certificates. You can do whatever. Then you take your artifact, you sign it, and then you publish both the artifact and its signature. Then if you are doing software supply chain security according to SigStore in the open source space, you also have to have some sort of log added to the Recore transparency log that says where this artifact is coming from, who signed it, when was it signed, what certificate was it used to be signed. In the log, there is also the public key, so you can verify the signature. And then as an end user, as a consumer, we can use those certificates to verify that the artifacts have been signed by the people who claim they have signed them, right? And so this is essentially what establishing trust means, right? This is a very long way to say, I have a distributed build system which contains people, humans, and computers. And as my software is going from where it's built all the way to where it's running, I can sign and verify the signature, so I can establish trust and verify trust across this entire process. Make sense? All right. I'm going to show you an example later, and you will get the point. The third thing that the SigStore project came up with is this thing called SBOM, Software Bill of Material. What it is, essentially, it's SBOM to software is basically what ingredients are to a recipe. When you are cooking a dish, your ingredients are essentially a set of things that you need to make the dish. In the SBOM world, that's essentially the list of binaries, files, contained inside the binary, inside the artifact. So you have an artifact, which could be an image or a binary or library, and then you attach metadata to that artifact, which is your SBOM, your software bill of material. Why this is important and why you have to care? Many reasons, one of which is in the European Union came up with a regulation called NIST 2.5 or something, which by 2025 or 2024, I don't remember, if you work for a company or for an organization that operates in the European Union and that operates in a list of predetermined industries which the European Union consider as critical, healthcare, energy, blah, blah, finance, blah, blah, then you have to have SBOM available on demand. Essentially, you have to generate SBOM, store it, and if the government or the regulators ask you for it, you have to be able to provide it, right? So this is why you should care. If I was talking to an American audience, I would say, this is SBOM, move on with your life. But we have to care because this is going to be important. Yes? I think they are looking into it, but I don't think there is a regulation yet. Like as in a law that have been written, agreed on, and voted. In the European Union, it was voted last year, so it exists. And it will be enforced in 2024 or 2025, I don't remember. So there are multiple ways to generate SBOM for artifacts. If you are using Docker, Docker has an experimental feature called SBOM, so Docker X SBOM, and it will generate SBOM. There are two common formats, either CycloneDX or SPDX. And I'm going to show you today one tool that I use for doing this. So basically, putting all of this together, the SLSA framework is there to is a set of practices that your build system have to follow in order to meet certain security requirements. SBOM is metadata that you add to your artifacts. And the combination of these two things is one potential way or one implementation of what we mean by software supply chain security. Right? Make sense? Any questions? OK. One actually, before I move on, one very common use case for SBOM, which we at Google were seeing a lot of customers asking us for it. Again, I'm not pitching a product here. I'm just talking about an idea. One way people are looking into using SBOM is in typical organizations of medium size, you basically have a bunch of GitHub repositories across all your microservices because all of your teams own and operate one or multiple microservices, and each of these microservices is stored in individual GitHub repositories. And in cases when you have a vulnerability or somebody just come and ask you, hey, are we using any open source software under a specific license, right? It's very difficult to answer this question if you have to go and check every single GitHub repository, right? With SBOM, what you can potentially do is you can have a process to generate SBOMs for all your software, store that SBOM somewhere in a data warehouse typically, and then now you have basically a searchable database that you can use to say, do I have this library somewhere in my software, or do I have a version or a library which is released under a specific license somewhere in my microservices, right? In my source code. Why this is becoming important is because, and I think today is a really good time to talk about this. You all heard what happened a few weeks back with HashiCorp changing the license of Terraform or all their products from, what was it, Mozilla, MPL to BSL, which in some cases, if you are using Terraform or if you're using HashiCorp products, you could be violating the license if you don't meet the requirements for whatever the fucking license means. But basically, like today, there is a very high chance that you are using software inside your source code which is released under a license, and you are violating that license. And if somebody in your company cares, or if your lawyers cares and come and ask, are we using anything released under BSL, for example, the business source license, then using something like SBOM, you can easily answer this question instead of sending a Slack message to all your developers at here, can you please check if you are using a library, and then relying on people's goodwill to figure out the answer. So let me show you what this could mean in practice. This is a very dumb example, very simple. I do have a container image here. It's written in Go. It's a very simple Go app that just says hello world. So I'm going to build it, and Docker images. So I have my container here, and I'm going to tag it. My demo doesn't work end-to-end, but I'm just going to show you part of it. So I just give it a tag. That long URL you see there, that's just like the URL of our artifact registry, but it can be whatever. Then what I'm going to do is I'm going to push this container image to a remote artifact registry, and I'm going to grab the signature, the SHA, right? And no, it's coming, hopefully. Yes, so I have my SHA here. Then what I'm going to do is I'm going to go ahead and use Cosine. So one of the things I talked about earlier is this tool called Cosine. It's a command line tool, which one of the things it does, it allows you to sign images using basically a key, a cryptographic key. So the way it works is you run Cosine with the sign command. You give it -- key. In my case, I am using a key coming from Google Cloud, GCP KMS. KMS stands for Key Management System. So that's our managed HSM in the cloud. Every single cloud provider has one of them. Cosine is explicitly designed to be agnostic. So it would run with anything, AWS, Azure, Microsoft Azure, same thing, Google Cloud, your own HSM, your own key that you generate with SSH, keygen, whatever, it doesn't matter. As long as it's a asymmetric cryptographic key, which is public, private, it would, like Cosine can use it. So I just give it which key I want, and then I tell it which container image I want to sign. So that's the third line. And then you see at the end of the third line, there is a -- tlog upload false. That's essentially transparency log. So the record transparency log I talked about earlier. I'm just telling Cosine, do not add an entry to the transparency log that says I signed this image, because I'm signing a private image. This is my own software. If I was doing this for open source, I would just use Cosine to sign the library and also add an entry to the transparency log for transparency reasons, right? So I can run that. That would sign the image. And once it signs it, it actually pushes the signature and adds it to my container image as metadata. So this is Google Artifact Registry. Again, doesn't matter. I can go here. This is my image. It's the one I pushed earlier. And here, I have basically a JSON payload that contains the signature. You can see there, it's a signature in the bottom line, right? So now that I have this, well, one of the things I can do is, imagine this is me as a developer. I built this image. I signed it. And all I have to do now is, well, I published it and signed it. Now all I have to do is I have to tell people, hey, this is my container image, and this is the key I used to sign. And then they can take my public key and then use it to verify that it was me who signed the image, right? So how can they do that? Well, they can just use Cosine the same way to do the verification, right? So Cosine has a verify command. Same thing, which key to use, which container image, ignore the transparency log, and then it says a bunch of gibberish, but you can see there the signature was verified against the specified public key. So this is essentially Cosine telling me, yeah, this image was signed with the key that you told me it was signed with, right? And this is a very simple, very dumb example of what we mean by establishing trust, right? So I'm doing everything from my laptop because I'm a single person now, but basically you can imagine this as I built a container image, I signed it, either manually like I did, or maybe as part of my build system. or part of your GitHub action build system or whatever, right? And then I have the signature stored, and then anybody who wants to pull that image, they can just use the same tool, use the public key, and verify the signature of my image. Make sense? I can also generate SBOM if I want. You can use Docker, you can use whatever. Again, just to drive the points further, I like to use Sift. Sift is an open source tool that can be used to generate SBOMs. Essentially, very simple. Sift, the container image, generated in SPDX format, and then I write it to a file, and this is how SBOMs look like. It's basically just a text file that essentially what it does is that it unpacks the container image and looks at every single file in the container image, and then just puts an entry for every single file. So that's basically all the files inside my container image. It's actually very handy. So the Sift is very handy if you're troubleshooting a container image. Like if you have a container image and something is not working, you can just use Sift to generate the SBOM and then search in the SBOM for whatever you need to search for, right? Instead of trying to unzip, because you can technically unzip a Docker file. You can take a container image and then unpack it. Instead of doing that, you can just generate SBOM and use SBOM to look what's inside the container image. Then what I can do is one other thing I can do also with Cosine is I can attach the SBOM to the container image. So this is basically, what it will do is it will add another entry to my container image, which would be so this is the SBOM itself, right? You can see there in the media type it says text. So it's just like extra metadata which is added to my image. And if I want to go even further, what I can do is I can sign it, right? So I need, give me 1 second. Why is this thing here? Go away, okay. I can take the SHA of this thing, not that thing, this thing, and then I can put it there, and then I can do this, and then I can use Cosign to sign the SBOM. So this way I have both trust in terms of who built the image, but who generated the SBOM. So I can both verify that the container image is coming from the person they said they're coming from, but also that the SBOM is coming from the same person, system, machine, server, whatever. And that would just add another metadata. And this basically contains the signature of the SBOM, right? One other thing that this Cosign have, which is not working in my case, but I'll just explain it, and hopefully you will understand it. They have a policy controller. How many people here are not familiar with Kubernetes? One person, okay, 2 people, 3 people. Okay, so in the Kubernetes world, there is this thing called, this concept called the policy controller. What's a policy controller? Essentially, it's basically before you deploy things, you can tell the cluster, go talk to this piece of software and tell it what's happening, and then that piece of software will tell you if this action meets the policies that are in the cluster, right? So Cosign, the people who wrote Cosign, they wrote a policy controller for Kubernetes. You can deploy it. It's open source. You can just deploy it on Kubernetes. And then you can configure it with a policy like this. And the policy essentially says, whenever I try to deploy images, do you say where it says image glob ***? So whenever I try to deploy whatever, then just verify that that image have been signed with that key, right? So essentially, this is just doing the Cosign verify inside the cluster for me. So once I deploy this, which again is not working for me, but I can just take any namespace in Kubernetes and then put a label on it to say, please include this namespace in the policy checks. And then if I try to deploy something, an image which haven't been signed by the key, then it would not be deployed, and it will only allow me to deploy stuff that have been signed by the key that I told the policy controller to verify against, right? Very simple. Yeah, so that's it. That's essentially what Cosign can do. I know that I am probably ahead of time. I don't need really the whole hour. I want to leave as much time as possible. So I don't work for sales, so I don't really care if you use Google Cloud or not, to be honest with you. But I do still want to talk about some stuff that we have that are free, that you can use them. I'm going to only focus on free stuff. Well, this is not free, but this is cool, so I will talk about it. Cloud Workstation, I think most of you are probably familiar with the concept of CDEs, Cloud Development Environment. So ephemeral environments in the cloud where you can just like dump a bunch of code, do some development, and then kill it. Cloud Workstations is kind of the same. It's not technically ephemeral because they are full-blown like development environments that can be based on the most common IDEs. So Visual Code is the basic one, but it supports IntelliJ, it supports PyCharm, it supports PHP Storm, it supports a bunch of them. You can also customize it. You can bring your own image. It's just a Docker image, so you can put your own tools in it. I do like it. What I don't like is the fact that I have to use it from the browser, from the web. I really hate the web. I don't want to be coding in the browser. That's the default mode, right? So if I don't want to do that, what I can do is I can just basically run an SSH channel, and then I can use the SSH plugin in Visual Code to connect to my remote workstation. Actually, what I've been doing so far is what looked to you like Visual Code, but this is not Visual Code running on my laptop. This is Visual Code running on a remote workstation, right? You can see there, when I do new name, it says Linux workstation. My laptop is a Mac, right? So essentially, I have a heavy client that I am using, but the back end of my workstation is in the cloud. If you create a cloud workstation using IntelliJ as an IDE, then IntelliJ themselves, they have something called IntelliJ Gateway, which looks like Visual Code. So you deploy it physically locally, and then you use it to connect to a remote workstation. So it gives you the typical interface of IntelliJ, but your workstation is in the cloud. Why this is important is an example. I will give you an example, and my problem with this example is that I have done this talk multiple times, and so far, no one have managed to neither prove me right, neither prove me wrong. So let's see if Copenhagen can do it. If like most of you have laptops from your companies, and most of you just do a git clone and have a copy of your code of your company on your laptop, right? So technically, you have intellectual property of your company on your laptop, unless your code is obviously public, which is not a problem, but if your code is private, it's on your laptop. So if I really, really, really want to steal your code, well, I can just follow you to your hotel, right? Go into your room when you're out having a beer, take your laptop, try to boot it, try to guess your password, maybe take the hard drive out, and then I have all your code, right? Have this happened to anybody before? OK, so then I will continue asking this question until somebody tells me it have happened. Again, this is one of these things where we really don't have data about whether this is happening in reality. I would say, again, this is a non-zero chance that it might happen. If somebody really wants to steal intellectual property, this is a very easy way to do it. But if your workstation is in the cloud, and if your source code is not on your laptop, then this is a no problem, right? If you don't have code on your laptop, then it's not a problem. This is what we've been doing at Google for a very long time, by the way. I've been at the company for 10 years, even before cloud was a thing. And these laptops from the company, these are considered untrusted devices. I cannot clone code from internal repositories on my laptop. I can't have a local copy of my laptop. All my development work is done in a remote cloud environment. Again, you want to use it, fine. You don't, it's OK. Again, just to prove to you that I don't really care too much, there is two more. I think you are all familiar with GitHub Dev. GitHub.dev. So GitHub.dev is the same concept. It's a remote workload, the development environment in the cloud. And if you don't care about GitHub, there is a company called Gitpod, which does pretty much the same thing. So they're all doing the same thing, just like a cloud development environment, which sits in the cloud. What's cool about Gitpod is that they have actually a GitHub app. So you can deploy the app in your repository. And then when you open the GitHub repository, it has a button that you click on it. It fires up Gitpod. It creates an environment for you. And it gets clone the code from that repository into that environment so you can start working on it. Make sense? Right? Two more things that we have you can use for free, or not, really up to you. We have a plugin for Visual Code called Google Cloud Code. It's a plugin that you can deploy in Visual Studio, and it gives you basically a bunch of way to interact with your cloud environment. You can deploy things, doing right-click deploy. You can do a bunch of things. We are adding a thing called Cloud Code Source Protect. What it is, essentially, it's a continuous vulnerability scanning tool in your IDE. It supports Python, supports Node.js, Go, Java, and maybe something else. And essentially, it looks at your requirement file. It's your dependency file, your pom.xml or your Node.js dependency file, whatever you call it. So it looks at your dependency file. It looks at the libraries, and then it checks against the CVE database, and then it gives you reporting in this problem tab to tell you this library has a vulnerability, right? And this is in preview, but once it becomes available, it will be free. The other thing which is free is assured open source software. You can ignore the first one. I'm not going to talk about it. But assured open source software is GA, so it's available for anybody. So what it is, it's basically a combination of 250 plus Python and Java libraries, the most common ones, that we take, we test them, we do some fuzz testing, and we make sure they don't have vulnerabilities, and then we offer them for free. And the list of these libraries is going to expand eventually, and we're going to also support other open source tools. Essentially, in other terms, instead of pulling your dependencies from Maven Central, you can just pull them from us, and then you can make sure that they are signed and verified and tested. And there is no such thing as vulnerability-free, but they are as vulnerability-free as possible. And that's it. That's all I have. Thank you very much. I hope it was useful. Do you have any questions for me? I know I was just after lunch, so I hope that my soothing voice didn't put you to sleep. Yes?
In order to get to SLSA level 3, for instance, am I right in assuming that all your dependencies also need to be SLSA level 3?
Dependencies of your code?
Yeah.
No, so dependencies of code is outside of the scope of SLSA. Because SLSA focuses on how do you manage the source code, not where the source code is coming from. It's just how do you manage it. So how do you store it? How do you store the commit history? Do you have peer reviews and all that stuff? And then the build system. Where your code is coming from is outside of the framework of SLSA itself. But if you are using, let's say, for example, you want to use a third-party CI pipeline, and you have your own CD pipeline, if your CD pipeline is SLSA level 3 compliant, then you want to make sure that the CI pipeline you're using is also level 3 compliant. Does this make sense? Right. Actually, by the way, Argo is already SLSA level, Argo CD. They went through a certification process very recently, and it is already level 3 compliant, the newer versions, and I think Prometheus as well. So not Prometheus the software, but the way Prometheus is built is following, like all their build pipeline is following SLSA level 3. And there is more and more. If you go to the CNCF blog, you know the CNCF, the Cloud Native Compute Foundation, they have a blog, and each time they do a certification process for one of their projects, they publish it. And they say, oh, this project is SLSA level 3 compliant, whatever. They work with ChainGuard, is the company that is one of the companies that has those people that can help you do the certification process. Other questions? All right, well, either that was very useful or no one understood anything. So, I mean, either way, you can just tell me on Twitter. Thank you very much.